Welcome to the deep dive. Ready to explore something pretty fascinating?
Always.
Awesome. So today we're diving into the world of deep learning. You mentioned wanting to get a better handle on it, maybe for that meeting coming up, or just out of curiosity.
Yeah, definitely. It's one of those things you hear everywhere, but it's hard to get past the buzzwords sometimes.
Exactly. So we're going to try to cut through that. We're using the Wikipedia article on deep learning as our guide.
Wikipedia, huh? Well, it can be dense, but it's a good starting point.
For sure. So first things first, what is deep learning? The Wikipedia article defines it as a type of machine learning that uses artificial neural networks with multiple layers to analyze data.
Okay, a mouthful, but that's Wikipedia for
Right.
Okay.
So can we break that down? What does that actually mean in plain English?
Sure. So think of it like this. Imagine a network of interconnected nodes, almost like a digital brain. Each node's like a tiny little processor, and they're all connected. Now, the deep part comes from how these nodes are organized in multiple layers.
So the more layers, the deeper it is.
Yeah.
But why is that so important?
Good question. It's all about complexity. Each layer extracts increasingly complex features from the data it's looking at.
Okay, so like what kind of features?
Well, it depends. Think about it visually, like a building with many floors. The first floor, maybe it just sees basic shapes like lines and edges. But as you go higher, those layers, they can recognize more intricate stuff, like
Yeah.
faces or objects. That's the deep part.
So it's like the network is learning to see the world in a more sophisticated way with each layer.
You got it. And the crazy thing is, these deep learning algorithms, they figure out those features on their own. We don't have to tell them what to look for.
Whoa, so no hand-holding required. They're actually learning from the data. That's pretty wild.
Right. That's what makes deep learning so powerful and is driving a lot of the advancements we're seeing in AI right now.
So speaking of AI, I noticed that Wikipedia mentions some surprisingly early work on these neural networks, like way before all the hype we see today.
Yeah. The roots of deep learning go way back, like way back. There's this thing called the Ising model, a non-learning neural network from the 1920s, almost a century ago.
Wow, I had no idea it went back that far.
And even Alan Turing, the guy behind the whole idea of computers, he had ideas about recurrent neural networks back in 1948.
That's incredible. But hang on, it wasn't all smooth sailing, right?
Yeah.
Wikipedia also mentions something called the AI winter.
Ah, yes. The AI winter refers to these periods where research funding and interest in AI just declined.
What, like people lost faith in it?
Yeah, kind of. There were these high hopes, but progress didn't always meet those expectations. So you had periods like in the 70s and again in the late 80s, early 90s when things slowed down.
I can only imagine what those researchers must have felt. Like working on something groundbreaking, but no one's really paying attention.
Yeah, it must have been tough. But even during those winter periods, there were still these amazing researchers pushing the boundaries. People like Alexei Ivakhenko, who built a network with 8 layers that was unheard of at the time, and trained it using a method that predates even backpropagation.
Backpropagation, that rings a bell.
Yeah, we'll get to that later.
Yeah.
But the point is, Ivakhenko's work was pioneering. And then you have Kunihiko Fukushima, who came up with the ReLU activation function in 1969.
Okay, hold up. ReLU. What's that?
It stands for a rectified linear unit, and it's basically a mathematical function that's still widely used in deep learning today. It's kind of a technical thing, but basically it helps to make training these deep networks much more efficient.
So not just some random map concept. It actually had a real impact on the field.
Absolutely. And then, of course, there's Jürgen Schmidhuber, who did a lot of work in the 90s on things like self-supervised learning and hierarchical recurrent neural networks.
So even during those AI winters, the seeds of what we see today were being planted.
Exactly. Schmidhuber's work, especially, was really ahead of its time. But something big changed in the 2010s. That's when deep learning really took off.
Yeah, that's what I've heard. So what was the game changer?
Well, it was a few things coming together at the right time. You had improvements in algorithms like backpropagation becoming more efficient, which allowed researchers to train much deeper networks.
Got it. So algorithms were getting better. What else?
Hardware. GPUs, the processors we use for graphics and gaming.
Yeah, those things are beasts.
Right. They turned out to be perfect for the kind of parallel processing that deep learning needs. It was like giving researchers a massive boost in computing power.
Makes sense. More power, better algorithms, anything else.
Data. The internet had exploded by then. which meant huge data sets, like ImageNet with millions of labeled images, were becoming available.
Ah, so these algorithms had more fuel to learn from.
Exactly. And all of this culminated in a big moment for deep learning. The 2012 ImageNet competition. There was this deep convolutional neural network called AlexNet, and it just blew away the competition.
AlexNet, huh? Sounds like a champion.
It was a turning point. AlexNet showed the world just how powerful deep learning could be, especially with image recognition.
And I bet that sparks a whole lot more interest and investment in the field.
You bet it did. And we're seeing the results of that today in everything from our smartphones to self-driving cars.
So it sounds like we've gone from these early, almost theoretical ideas about neural networks to a full-blown technological revolution.
That's a great way to put it. But we've only scratched the surface here.
Right. We still need to unpack exactly what these neural networks are made of and how they actually work.
Totally. And then we can really dive into the crazy applications and, of course, talk about the potential risks.
Sounds like a plan. So deep learning's had this huge impact, but where do we actually see it in action in our everyday lives?
Well, I bet you use it more than you realize. Ever talk to your phone.
Oh, you mean like using Siri or Alexa? Yeah, all the time.
Yeah.
Especially in the kitchen when my hands are full.
Exactly. Or think about voice to text. Deep learning's completely revolutionized how those systems work. They're so much better at understanding us now.
It's true. They used to be kind of clunky, but now it's almost like talking to a real person. Well, almost.
Right. And that's because deep learning algorithms can analyze these massive amounts of speech data, learning to recognize all the tiny nuances of human language, things that would be impossible to program by hand.
So it's not just following a set of rules, it's actually learning the patterns of how we speak. That's crazy.
Yeah, it's pretty amazing. And the same principles are being applied to image recognition, too.
Oh, yeah. Like what kinds of things?
Well, everything from those self-driving cars everyone's talking about, to facial recognition, to medical imaging, deep learning is changing the way we interact with the visual world.
Okay, so now it's not just understanding how we talk, but how we see, too.
Exactly. And it's not stopping there. Deep learning is also shaking things up in natural language processing, or NLP for short.
NLP, right, I've heard of that.
Yeah.
Isn't that all about how computers understand, the meaning of language?
Exactly. And deep learning's fueling some major advances in that area. Think about things like machine translation, for example.
Oh, yeah, like Google Translate. I use that all the time when I'm traveling.
And it's gotten so much better in recent years, right? That's thanks to deep learning algorithms that can analyze huge amounts of text and learn the complex relationships between words and phrases in different languages.
So it's not just translating word for word anymore.
Nope. It's more about understanding the context and intent behind the words, which makes the translations way more accurate and natural sounding.
Wow, so deep learning is basically giving computers a crash course in linguistics.
Pretty much. And it's not just translation. Deep learning's also driving advancements in chatbots, text summarization, sentiment analysis, all sorts of cool stuff.
Okay, color me impressed. Now, Wikipedia also mentioned something about deep learning being used for drug discovery. That sounds pretty wild.
It is wild. Researchers are using deep learning to analyze these massive data sets of molecular structures. It's like they're searching for patterns that could lead to new medications and treatments.
So instead of spending years in the lab, deep learning can help speed up the process of finding new cures.
Exactly. It's like having a superpowered research assistant that can sift through mountains of data and point you in the right direction.
Now that's what I call progress. And speaking of pushing boundaries, what about this whole AI art thing I keep hearing about?
Yes, AI art. That's another area where deep learning is really shaking things up. We're talking about algorithms that can create everything from photorealistic images to abstract paintings, even music.
Wait, so computers can actually be creative? That's kind of freaky, right?
Yeah, it is a bit mind-blowing. These algorithms are trained on massive data sets of existing art and music, learning the underlying patterns and structures. And then they use that knowledge to generate something new, something original.
So they're not just copying, they're actually creating.
Yep. It's blurring the lines between human and machine creativity, which is pretty fascinating and maybe a little unsettling for some people.
We'll see. It definitely makes you think about what it means to be creative in the age of AI.
For sure. And these are just a few examples of how deep learning is being used. We're talking finance, cybersecurity, weather prediction. It's everywhere.
It sounds like there's no limit to what this technology can do. But, with great power comes great responsibility, right? What about the potential downsides? Are there any risks we should be aware of?
You're absolutely right. It's not all sunshine and rainbows. We need to be mindful of the ethical implications and potential risks too.
Okay, so let's talk about that. What are some of the things we need to watch out for as deep learning becomes more powerful? All right, so we've talked about what deep learning is and the amazing things it can do, but like you said, it's not all sunshine and roses. What are some of the potential downsides we need to be aware of?
Well, one of the biggest concerns is something called the black box problem.
We touched on that a bit earlier, but can you remind me what that is again?
Sure. Basically, it means that these deep learning systems can be super complex and hard to understand. Sometimes it's really difficult to figure out why a system made a particular decision.
So even the people who design them don't always know exactly how they work. That seems a little unnerving.
It can be, especially when you think about the potential consequences. Imagine, for example, a self-driving car.
Okay, yeah, I'm following.
And this car makes a sudden turn or a weird maneuver, maybe even causes an accident.
Oh, that doesn't sound good.
Now imagine the engineers who designed the AI system can't explain exactly why the car did that. They can't pinpoint what information it used or what logic it followed.
So we're essentially putting our trust in these systems to make decisions that could be life or death, but we don't fully understand how they're making those decisions.
That's the dilemma. And it's not just self-driving cars. Think about things like medical diagnoses or systems used in the criminal justice system.
Yeah, those are high-stakes situations. You really need transparency there.
Absolutely. If we're going to rely on these systems to make important decisions, we need to understand how those decisions are being made.
So how do we solve this black box problem? Is there a way to make these systems more transparent?
That's the million-dollar question. It's definitely a challenge, but researchers are working on ways to make these deep learning systems more interpretable so we can understand their reasoning better.
So it's like trying to peek inside the brain of the AI and see what's going on.
Kind of. We need to develop tools and techniques that help us understand the factors that influence a system's decisions so we can spot potential biases or errors.
Makes sense. We want to be sure these systems are making fair and ethical choices, right?
Exactly. And as deep learning gets more sophisticated and more integrated into our lives, these ethical considerations are only going to become more important.
Well, we've definitely covered a lot of ground today, from the basics of deep learning to its amazing applications and the potential challenges we need to address.
It's a fascinating field, and it's evolving so quickly, it feels like we're just at the beginning of this deep learning journey.
Totally. So for everyone listening, if there's one thing to take away from this deep dive, it's that deep learning is a powerful tool with incredible potential, but it's important to be aware of the challenges and to keep asking questions as this technology continues to evolve.
Couldn't have said it better myself. Keep learning, keep exploring.
Thanks for joining us on this episode of The Deep Dive. We'll see you next time.